Hello everyone and welcome back. In this part 2 we continue our work on this project, and the first thing we're going to do is setting up scene and assets which we already have from previous part. After that we will do simple Repuls effects, and I'll show you how I worked with effects layer in Solaris. After that lighting, rendering, and finally comp. Okay, but before going further, let's quickly have a look at the whole setup from the beginning. Let's start with these ones, and here we just declare in scene structure. After that we reference in camera and creating camera edit loop node. I'm applying lens shader to camera. Let's dive inside material network and we can find Karma physical lens shader here. We're doing full CG shot, and in this case we can do whatever we want, and we can do some kind of experiments. That's why I decided to use lens shader, and I'm using vignette in settings and lens distortion. After that we reference in road without materials. That's just a geometry layer for now. After that we reference in hero building and two ramen shops. That's just the same asset but transformed and translated and rotated. After that office buildings and bike shops. Yeah, all works. After that we go into props, and here we can find street poles and bicycles. Finally, two more props. One of them is umbrella. Okay, after that we're going to effects. We don't have any effects for now, and they go into lighting. Here we can find just a single dome light. In the end we have Karma render settings node with XPU enabled, and let's have a look what we have for now. Let's restart rendering, and it will need some time to have all the data updated on GPU. Okay, we have our first render completed, and 10 seconds for this half resolution gray shade. Quite fast, but again we do not have any materials applied. That's why we have these render times. And let's snapshot and have a look at it closer. Okay, and the first thing I notice here is quite high noise level. If I increase brightness we can see it. We need to do something with this, and I think already at this point we can talk about noise level and how to reduce it. Let's close, and I'll create one more Karma here. I don't want anything to be changed in this Karma settings node. That's why we will have a look at it here. When we have CPU engine enabled, we have a lot of options: primary samples, minimum and maximum secondary samples, indirect samples quality, lights quality, and some volume options. We're not going to talk about volumes for now, only about geometry. But when we are switching to XPU engine, we have only two options left. I mean, for lighting and sampling quality. So the first is primary samples, and the second is light sampling quality. And I think we can talk about this one. This parameter here in Karma node, I mean, is a global parameter for all the light sampling qualities for all the light sources in the scene. What I mean? I mean that in every light source we create, we have the same parameter. We can find it in Karma tab and in sampling quality. By default, we cannot tweak it because it is set to do nothing, but we can set it to set to create, and in this case we can tweak this one. And I would prefer not to use this light sampling quality global parameter. Instead of this, I want to use this sampling quality parameter for light sources which really needs more sampling quality. I mean we can look at AOVs which we have and decide if this light source needs more sampling quality or not. So let's set it to something greater than 1, 2 for example. And yep, it's done. Let's do a snapshot. And compare. Yeah, looks better. Let's set it to 5. And wait a little bit more. But as you can see, render times are almost the same. Let's do a snapshot. And compare the first and the last ones. And we can see that result is much better. Here we can see not so noticeable noise, but yeah, I like it. And what we can say, we can conclude that this parameter will help us to reduce noise level, and it really helps. But when I applied all the materials and added indirect lighting here, I noticed that this parameter is not working as expected. I mean, when we have grayshade, we have this really great difference here. But in more complex scenario, for example, in my case, I had something about 70% increased render time, but noise level was still really noticeable. I mean, when I worked with this parameter with shaders and more complex lighting. So for myself, I concluded that I don't want to set this sampling quality to high values when I'm working with Karma XPU. Instead of this, I decided to work with primary samples only. And that's what I wanted to talk about in this simple grayshade shading scenario. Let's continue, and now I think we can replace all of these geometry USDs with the final ones, in which we have materials, I mean. Okay, let's delete this one, we don't need any more. After that, from the beginning, I just replacing all of these USD files step by step. Let me quickly do this. Replacing hero USD, after that ramen shop, office building, and bike shop. After that, we're replacing street pole, and just to remind, we have one street pole USD and 4 asset reference node. That means that we referencing this asset 4 times here. And the last one is umbrella. Yep. We replaced everything we have. And what we can see, actually there is no difference between geometry layer USDs and the final ones in viewport, because I haven't prepared any preview surfaces for these assets. That's why we can't see any difference. Okay, let's render this, but I would prefer to start with CPU engine just to be sure that everything works well here. Let's go to CPU and restart. Yeah, I can see that all the materials applied here. We already have some AOVs, which we actually do not need for now. I want to see Albedo first, and I can see that all the textures applied. But at the same time, we can see this black something, and we do not have any indirect lighting. Because these curtains are not transparent, they're just almost black, and this black part is a water surface, which do not have refraction limits now. That's why it is black, and also we will need to transform it. Okay, let's do this. We can quickly switch between viewport and rendering with Shift-R combination. Okay. I already have prepared nodes here. I'm just applying them. For road, This render geometry setting is for dicing quality and true displacements enabled. This render geometry setting is for visible part of the road, I mean. This one is for invisible part of the road. We did the same things in asset preparation step, but we can just apply all the same things to be sure that everything works well. Sometimes I don't want to go back to the asset scene and tweak something here. I just want to have everything in the final master scene. Okay, and just transforming what is surface primitive and applying it. Okay, let's have a look at it now. Yep, now we have this road visible, and water surface is only on the borders. That's great. Let's stop rendering for now. What else we have here? Also, we have some light blockers. Let's just apply them. Where? I think we can apply it here. And I'll show you them. There's just a couple of blockers here. And to close these holes in these buildings. Yep. And here a couple of blockers. So nothing special. After that, we also have these render geometry settings, and let's talk about it. I think I'll plug it somewhere here. And the first one is render geometry settings with reflection limits. Let me show you what I got in the limits tab in camera render settings first. And you can see that everything is 0 except color limits. That's because I decided to apply limits only for primitives that really needs it. Because bouncers are really expensive, and I think it is a good idea to apply these limits only on necessary parts. And reflection limits, I set it to 1. And for primitives which have low roughness or some, mirror-like reflections. For example, water surface really needs these reflection limits. Refraction limits are the same for water surface, and also I added it for transparent curtains and for all the transparent or refractive parts, I mean. I don't have any diffuse limits here because we do not have bright and contrast lighting here, no bright spots, and actually this diffuse limit contribution won't be really noticeable, but render times will be quite high. And also I'm removing shadows for curtains because again, these shadows are almost not visible. But render times are higher. That's why I decided to set render visibilities for them and excluded shadows. That's what we have. Okay, again, the idea is really simple, to apply limits only for necessary parts. I think it's a good manner to work like this. In this case, your render times will be optimized, and yeah. That's what I wanted to talk about. Okay, let's start rendering now. Restart. And now we do not have these black parts anymore. And I think now we can stop rendering and switch to XPU engine. So the rendering completed, and we have 47 seconds for this first pass half resolution render with all the materials applied. Also we have limit settings here, but I still see this strong noise, and we need to do something with this. Let's go to the snapshots, and I prepared 3 renders. which I'm going to show you. The first one is all the same that we now see in viewport. I mean all the same settings. Let's have a look at it closer and make it brighter. Yeah, now we can see this noise. And I have one sampling quality for light source and 128 primary samples here. Let's compare with the second one. On the second snapshot, we have 5 sampling quality for light source and 128 primary samples. So primary samples are all the same. And if we are looking at direct lighting contribution, for example on this roof, we can see that situation is much better, of course. But if we have a look at these refractions, maybe on these curtains, situation is almost the same. It's still really noisy. Also, we can compare render times 50 seconds for the first one, and for the second one is 1 minute 16 seconds. So the render times are higher, but result in refractions is all the same. Now let's compare with the third one. On the third render, we have one sampling quality for light source, but 256 primary samples. And if we compare with the second snapshot, we can see that in direct lighting contribution, it's a little bit noisier. But at the same time, in these refractions, we have better result. Now it is much better. And the render times are almost the same. That's why I decided to stay with primary samples instead of tweaking light sampling quality for some of light sources. So, but anyway, result is noisy. And in this case, we need to use denoiser. Let's have a look at it. How can we denoise this render? There are two options which I know. The first one is to render it with exported normal and albedo AOVs and apply denoiser in COP network. Or the second one, which I prefer here, is to apply denoiser on the render itself. And in this case, we need to go to image output and to filters tab. And here we can choose denoiser we may want. In my case, it will be Intel denoiser, but let's first set it to 156 and choose the denoiser. It is not going to restart as I see, and I think in this case we need to restart rendering and wait a little bit. It's done, and let's snapshot the result. Also here we can specify AOVs which we want to denoise, and of course we will need albedo and N AOVs exported, as you can see here. Let's compare results. And of course now we don't have noise anymore, but at the same time we have a blurry result, unfortunately. But situation will be better when we increase resolution of the render. We will do it later. So for this scene we're going to use denoiser. Let's talk about AOVs. I think we can close this window, and let's have a look what we got now. You already noticed that we have some AOVs exported, and for this project and for final comp, I decided to use only beauty passes per light and not to split render into direct and indirect contributions, because as I see, render itself is not so bad, and I decided just to stay with it. So we have beauty pass for our single environment lighting and just some technical AOVs. But anyway, I'll show you how to export all the essential AOVs. Beauty, split it per LP tag. LP tag, it's let's say that it's a name of your light source here. On every light source that you have in the scene, you can find this setting and, for example, name this light source. In my case, for environment lighting, I have LGT and LP tag. After that, we have beauty unshadowed and shadows. Thanks side effects for these options, and I hope now we don't need to create any shadow made materials or something like this as it was in Mantra. And as I remember, it was added in some of the latest builds, maybe, but I'm not sure. Let's go with combined, because I do not have diffuse limits, and in this case we won't see anything in indirect diffuse AOV. So all other things are not necessary here. Reflections and refractions. In this case, we need to have direct glossy reflection per LP tag and indirect glossy reflections, because we have reflection limits, of course. The same, and the glossy transmissions. We will see refractions here. After that, we can export chord layer, because for some geometry we have chord layers. Okay, that's it. We do not have any emissions here, and visible lights too, but we'll have it later. Let's leave it for now. No volumes, subsurface scattering we already have. Subsurface, in this AOV we can find both subsurface and translucency, actually. Okay, albedo we already have. All right, with component level output, that's it. The next step is ray level output, and here we got some technical AOVs, let's say so. World space, depths for defocus, and normals for denoiser, and maybe we may want to use it in comp. Okay, let's go to the extra, and here we can see cryptomate. And I'm happy with just a crypto object and crypto materials. That's enough, as for me. And let's have a look at it now. Yeah, we can have all of these services here. Let's check it. Let's start with diffuse, combined diffuse. Right. Let's look at it. After that, we can go to the direct glossy reflection. We can find it here, and indirect glossy reflection. We can see these mirror reflections on the water surface and on other bright parts. For example, I applied reflection limits on metal parts. Yeah, we can see it. After that, we can go to glossy transmission. And interesting thing that we can use we can see transmissions not only on really transmissive geometries. I mean, for example, on these curtains, but also on chord materials. And I suppose that's what we can see under the chord layer, but I'm not sure about that. Okay. That's chord, that's glossy transmission and chord layer. Yeah, only chord. So I think that's it. That's all we have. Or not actually, subsurface. But we don't have light sources behind this subsurface parts, so that's why it's almost not noticeable, but in some cases we may see it. But not now, of course. That's all we have, and as you can see, all the essential AOVs here. And if you want to do comp later with these AOVs, that's what you can have. Let's continue, and now we're going to create simple Repuls effects, and I'll show you how I worked with this task. But first, let me quickly clean this mess. Maybe move it something here. And yeah, What I'm going to do, first I'm going to export some necessary parts of this master scene and use them to create effects. Let's go to effects heap file and let me show you what we have here. I'm in stage setup. After we exported some parts from the master scene, we sublayering them here, and after that we're going to effects with layer break, because this layer break isolates effects layer, and we can export only this particular layer. In this subnet, inside of this subnetwork, we have simulation itself. I mean Reple Solver. After that, we import in this simulation from SOPs to LOPs and write in the final usds. That's what we have. But first, let's export these parts from master scene. Let me cut this and paste it here. I already have these nodes prepared, and let's plug it into FX. All starts with configure primitives here, but why I'm using this node? Let me show you. Render geometry settings. Let's plug it to the same output. And for example, I want to apply some of these settings to some primitives inside of this bike shop 1, for example. What I need to do, I need to choose something inside of this bike shop 1 here. I'm going to environments and I see that I cannot dive inside because now these blue primitives marked as instanceable and we cannot affect anything inside of them. And in this case, we can use configure primitive lop and choose these instanceable primitives and mark them as not instanceable only for exporting. So you can see it here. And I'm marking them as not instanceable. Let's have a look now. And now we can go inside and choose what we want. All the same with prune node. I mean, we can choose only if these parts, these primitives are not instanceable. And I'm choosing primitives which I want to export. Camera, sidewalks, I mean these borders, and of course road. After that, I'm just writing the final usd and use it to create effects. Now we have everything necessary to create Repulse effects, and let's dive inside SOP network. Here we can see setup, and actually that's not about creating some cool simulations. That's more about how I worked with FX layer in Solaris. Let's start with this LOP network. LOP import. We import in these parts of the road, proxy, water, and visible part. After that, we unpacking it because LOP import has only packed usds, and now we have polygons. After that, I'm splitting it into water proxy and road geometry. Let's go the right side first. Subdividing, promoting some attributes, and applying texture. After that, deleting everything not white. Cleaning and some copying. In this merge, we have these white lines, and I want to use these lines to create particles on them. And we will use these particles to trigger Reple Solver. But first, let's go to the left side. Water proxy, removing everything but a single polygon here, and projecting high resolution grid on this polygon. After that, removing not projected parts. And this grid we will use for Reple Solver. It's not high resolution actually, but that's more than enough for rendering. We won't see any noticeable results in viewport, I mean after Reple Solver, but on rendering we will see it. Okay, so the next step is projecting this grid on these borders. Let's do this. And again, removing unprojected parts. After that, cleaning to remove points and polygons. And I deleted these parts inside of these holes, I mean. Okay, I'm just optimizing this mesh. That's what I'm doing. After that, I'm creating grid and I'm creating group by bounding box and deleting this part too, because that's we can see it behind the camera. I mean, after that, we projecting these white lines on these parts and removing unprojected. Okay, and these white lines I'm using to create particles on them. And after that, I'm using copy to points and using spheres to for Reple Solver. I mean, let's have a look at it. Maybe for now we can scale it maybe 5 times, and that's what we have. Let's have a look at it. Or maybe I think we can have a look at this. Yeah. And we will have something like this. They appearing, and at the same time, or on the next frame, they are dying. That's exactly what we want. And again, we are using these spheres for triggering a Reple Solver. Okay, let's uniform scale set it to 1 back. This surface to ripples and droplets to ripple. Here we got Reple Solver. Almost everything default here except of this conservation, and actually nothing special here, just a simple Reple Solver. The only thing that I already mentioned that we can see the noticeable result from this Reple Solver on this low resolution mesh. And if we play back this, we can't see anything. In this case, I decided to export some attributes and just visualize this displacement. And in this case, we will see ripples. Yeah, that's good. All works well. After that, I'm recomputing normals, cleaning some attributes, and one more step before we are going to lobes. I need these borders again, and if we look at the simulation, for example, in this place, we will see these holes, which we may want to avoid. And I'm just projecting the edges on these borders with ray node. Let me show you how it was and how it now. And now we won't see any holes here. Yep, all good. After that we apply an usds form matrix here inverted. That's because I used some kind of that's because I used transforms in lobes, and I exported these parts with transforms. In this case, we need to apply this operation here. Okay, and one more thing I want to mention here, really important thing, is let's go to the primitives, and we have water name attribute and path attribute, which is inherited from the original geometries which we imported from lobes. That's really important. So we need these attributes to be saved. After that, we can go. Let's close this. We can go to lobes. And using Soop Import, we importing data from Soop network, I mean from this one, importing it into lobes. And we need, let me show you, Soop Import. By default, this Soop Import works this way. Sublayer style is add Soop layer as new sublayer. But we need to change it to copy Soop layer into new active layer. That means that we are creating something now, and we are working with the editable active layer in memory. That's what does it mean. So imported this mesh and changed this to copy Soop layer into new active layer. After this, I'm setting some render geometry settings. In my case, that's velocity blur, because we have velocities here. You can see it. Maybe some of them are not zero, right? But actually, this motion, we won't see this motion blur. And saving the final USD. When we got FX layer exported, we can sublayer it. And as an input, we have geometry from master sen, and let's sublayer. Yeah, that's what we have. Let's have a look at it closer. In the input, we have only proxy water geometry, but when we sublayering, we have this proxy geometry replaced with high resolution one with ripples, and even we can see these small ripples here. Surprise. Okay, some lighting here, and I decided to render the whole sequence just to see what we got, and I rendered it with Karma XPU. Let me show you this. Yep, I can see these small ripples. Looks good. It's not a rain actually. It's something about small droplets falling from, for example, from roof. That's what I wanted to achieve here. Yep, looks good. I'm happy with this result. And what's next? The next step is going back to master sen and sublayering it there. Let's copy it. And I think I'll paste it somewhere here. Let's plug it here. And yep, we can see this water surface with ripples. And also the same thing with other FX layers. Let me show you more FX layers which we have here. And the first one, actually I already have all of them prepared. The first one will be for these curtains on lanterns. I just passed them through Reple Solver. Let's have a look from this view. Sublayering, and yeah, just a small rotation as I see. Yep. The next one is for these small cards, and I want them to move. So it looks like a windy weather. Let's have a look. Yeah, works good. All right, the next one is the same thing, but for fabrics. For these blue fabrics. Let me show you. Yeah, all works well, and you can see that playback is quite fast. And finally, some water droplets on the surfaces. For example, I'll show you these water droplets on umbrella. Let me show you. Oops. Yeah, these small droplets. And yeah, that's it. That's all I wanted to show you in FX section. The next topic is lighting, and let's have a look at what we already have. We can find this dome light, and this environment light is main light source here. We're not going to have splitted dome lights or some kind of directional lighting here. Okay, that's a texture and increased exposure. In Karma tab, you can find these two parameters enabled, I mean sampling quality and LP tag. We already talked about sampling quality parameter in previous topics, but we're going to talk about it one more time in the rendering section. And you can see LP tag here. This LP tag is the name of light sources. And you can find this name in AOVs, but for now we don't have anything rendered. Okay, and also you can see here additional light sources which are used for this shot. And I would say that lighting in this shot is really simple and straightforward. I mean, if I wanted, I tried to put all the light sources in the places where they should be, let's say, in real life. For example, for this lantern, if I wanted to have lighting inside of this lantern, I just put light source here inside. And the shading, which we did in previous part, allows us to do that and not to fake anything. That's what I mean. All the same thing with these transparent curtains. I just put light source inside of these buildings behind these curtains, and it looked like some kind of light fixture inside. And we can see lighting passing through these curtains. Okay, also we can see more ideas how to use light sources, but I don't think we need all of them in daylight scenario. Okay, and the next one is, the next one is this background building, and here we can find these lights. Actually, I just replaced the original geometry of light sources with tube light sources, but we don't have these tube light sources now. That's why we can't see anything here. But again, I put additional light sources here. All right, and also I put lighting inside of this building, and it looks like something going on inside. And if I remember, also we have some lighting in this small room, if I remember right. So that's it. And I think the next step will be just to add light sources one by one and see what we got. Okay, let's continue working with these light sources. And one more thing I want to say, that for lighting we are going to use CPU engine instead of XPU. But why? Because, for example, when we are rendering from camera view with XPU engine, everything is okay. But at some point we may want to zoom, for example, to see this primitive closer, and in this case we will need XPU to be updated. Maybe some MIP levels updated or something like this, I don't know, but anyway we will need to wait, and I don't want to wait it. That's why I decided to use CPU, because for now it is much more responsive. That's what I mean. Okay, let's switch to the CPU. And for test, I think we can set primary samples to 6 and max secondary samples to 4. And all other settings default. Let's start rendering. Yeah, everything loaded really fast. But at the same time, we can see that even with this low sampling quality, rendering is not fast. That's because I'm working on a laptop and CPU here is really slow. I think on a good CPU it will be much faster. But anyway, it is enough to see what we have. Okay, let's go to the AOVs. Here we can find all the necessary, and maybe for now we can remove utilities, but let's leave it. And the only contribution, beauty contribution here, I mean, is from environment lighting. We can see it. And it's almost done. Yeah, it's done. We can see that Denoiser does a lot of work here. Okay, let's add more light sources. This one. And this light source is inside hero building. If we press enter in rendering view, we can find it. We can move it if we want, but I do not want to move it somewhere now. Inside of this hero building, behind fabrics and curtains. Yep. As about settings, increased exposure, just a simple spherical light, and I used color temperature. It works really well, instead of setting color for this light source. In Karma tab we can find LP tag, and that's just an expression which reads the name of this node. You can see it. Okay, let's go to AOVs. AOVs, yep. And if we increase brightness, we can see this subsurface effect. But if brightness is not high, this effect is quite subtle. That's because the fabric itself is quite thick and it has dark blue color. But anyway, I think this lighting contribution, this AOV, we can use for some night scenarios in comp, maybe. Okay, let's add more light sources. These four. These ones are for lanterns. It's called light bulbs, but I'm not sure that inside of these lanterns we have bulbs, maybe candles. I'm not sure about that, but let's stay with this naming. Okay, let's use this one first. Yep, we can see it. About settings, all the same, spherical light and low color temperature. That means that it is a warm lighting. In Karma tab, we can see the same expression for LP tag and active radius. This one is for optimization, because if we have infinite active radius, render times are greater. And if we have lower active radius, render times are lower. Okay, so what's next? We can see it in AOVs too. Here, we can make it brighter, but it's not make sense now. Okay, and let's press enter, and you can see that this one is inside of lantern. And I think the next one, yeah, we can have it. And the third. Yeah, all works. Last one. And let's move it. Yeah, we have all the light sources for lanterns set up. The next ones are for backgrounds, but first I think let's have a look at them. Shift R, and I want these four. Okay, as I remember, these ones have the same LP tag. Yeah, that's the same light source for AOVs, I mean. Okay, and let's plug it here. As I remember, that's for these light sources, right? We're just replacing mesh from these light sources with these real light sources. You can see it. Just a tube lighting. And increased exposure, color temperature, white lighting, something like this, I mean. And in Karma tab, we can find these settings: single-sided, render light geometry, because I want to see something here, not just an empty space. Light geometry, cast shadow. I don't think we need it actually, but let's leave it. And again, all of these tube light sources have the same LP tag. Let me show you this again. Yeah. Okay, let's have a look at it from camera view. Now we see that some parts are disappearing, but that helps. Let's Shift R and have a look at it. Yeah, now we can see something on the background. We can increase brightness, and actually I would recommend to set the active radius for these light sources too, because now it's too far. But maybe for some night lighting scenario it will work. We will see these reflections. Okay, let's leave it for now. And one more thing. Also, we can see reflections in water. That's good. Okay, let's add more light sources. These ones. Let's stop rendering and paste it. As I remember, some of them are for this built-in. I mean inside of it. Let's check. Yeah, this one. And this one is for this. Okay, and the first one was for this small room, as I remember, for this kitchen, right? Yeah, that's what we have. I think we can go to the camera and render it again. Yeah, this one. Subtle too, actually, but we have this reflection, that's enough. After that, this light source, and again reflections in water. That's the main thing here. And from this one we can see reflections too. Okay, and yeah, all light sources that we have here. And after we set all the light sources, we can include all of these AOVs for denoising. Let's do this. Go into XPU. Go into Karma render settings, and in image output filters. We already have denoiser for beauty pass, but now if we have a look at the render, we will see that when it's completed, we can see that we have denoise only on beauty pass, but these AOVs are without denoising. We need to fix that. You can see denoise and AOVs are not denoised. Result is really blurry, but again, we will increase sampling quality and resolution, and it will help, of course. Okay, let's go to the AOVs in the Denoiser tab, and we can see all we have. Let's one by one add them, but first I think we need to stop rendering. Okay, this one, and just one by one adding them. Let me quickly do that. And LGT inside the last one. Yeah. And let's restart rendering and see what we got. You can see these light sources before rendering started. You can control it here. If we disable this, we won't see them. All the same with camera and primitives. Let me show you. For example, if I'm switching this on and choosing some primitives, selecting them, this one, it is highlighted. You can see it. If we disable, it is not highlighted. So let's wait the render. Yeah, it's done. We have 1 minute 29 seconds for this render, and let's check AOVs if they have denoise or not. Yeah, now everything denoised too. And I think the next step will be rendering the same with Karma XPU. Now we can see that rendering with XPU completed in 1 minute 48 seconds. Anyway, we will need to increase sampling quality and resolution. But for now, let's have a look at AOVs. Contribution from environment lighting. Yeah. After that, inside of hero building. From lanterns. Yeah. The next from background. Yeah, all works. And let's check utility AOVs. I'll better here. We also have this empty emission. We don't have any emissions, but anyway, it exports it for some reasons. Okay, cryptomate, depths. Yep. normals, and world position if we may want to use masks in comp. Subsurface here. And yeah, maybe we forgot to include subsurface, and we will fix that, but for now we have all the necessary passes for comp. And now I think the next step will be going to rendering section. The rendering section I think will be the shortest one here, because we already have almost everything set up. I mean stage, light sources, and a viz with denoiser. You can see it here. At this point, I think we can quickly have a look at Karma render settings node and at parameters which we have with XPU engine enabled. First is resolution, and we will double resolution for final result. For now, it's only half. Path traced samples, and these samples are made here. We will be happy with 256 or 500, something like this. Two more settings, volume step rate. We don't have any volumes, so just skipping it. And light sampling quality. We already talked about this. And I wouldn't recommend to tweak this one, because this parameter is a global multiplier for all light sampling qualities for all light sources. Instead of this, you can go to any light source, for example, for this one, and find sampling quality here. And if this light source needs more sampling for direct lighting, you can increase it. Okay, and what's next? Limits. Or maybe one more thing here is, again, I decided not to set high values for this one in my case, because light sampling quality won't help me with indirect lighting contribution, for example, for refractions and indirect reflections. But render time is higher. And I decided to increase, instead of this, path traced samples, because these samples affects both direct and indirect contributions. That's what I mean. Okay, let's go to limits. We can see 0 for all the limits here except color limit. That's because we have render geometry settings, and here we specify necessary primitives and set in limits only for them. And for refraction limits, the same. In this case, your renders will be optimized, and render times too. One more interesting parameter here is Russian roulette cutoff depth, and this one will help to reduce noise level with indirect lighting, for example, for refractions. But after tests, I decided just to leave it default and again increase only these samples. Camera effects, enabling motion blur here, geometry and shading. Everything is default. Maybe yeah, this dicing quality scale is for render displacement, for example, and we can choose dicing camera, but let's keep it for now. And in shading type, we can find ray bias. This one may be useful, for example, if we're rendering with CPU engine and we render opacity hair. For example, we will need to reduce this ray bias. Okay, and what's next? Let's go to image output tab. Everything is clear here, I suppose. We already talked about it. Filters, here we can find denoiser, aspect ratio, data window NDC. This one is for overscan, and pixel aspect ratio. I don't know, maybe if we need to render something anamorphic like, in this case, we can tweak this one. Metadata, we don't need it. Deep output, luckily we don't need any deeps here. And in advanced, we just skipping it, everything default. So again, let's talk about render settings which I used. In my case, we have complex scenario with both direct and indirect lighting, and that's why I decided to stay with primary samples only, instead of tweaking light sampling quality. But if you have only direct lighting contributions, I mean if your limit's 0 for all the primitives and for the whole scene, I mean, in this case, I think it is better to increase light sampling quality. And maybe in some cases, when you have indirect lighting and it's really noisy, in some cases you may try to increase this one to quite high values actually. Okay, that's what I wanted to tell you about render settings with Karma XPU. Let's increase resolution, sampling quality, and do final render. Maybe you noticed that we don't have anything loaded in scene, because rendering with Karma XPU, I mean final rendering, requires a lot of GPU memory, and I don't want anything to be loaded even in viewport. Let me show you the difference. Now we have 10%, 11% memory consumption. If we load it, we have 70%. I don't want to waste this 6% because we have really a lot of things to render. That's why I created this empty null and looking at this one. So we can go to Karma render settings, set it to full resolution. We do not need any overscans here because we have rendered distortion, and we don't need any camera shakes, of course. So that we can double these samples. And yeah, that's it. We can go to mplay and try to render current frame. Okay, the final rendering completed, and here we can see result. Also, we see render time 12 minutes for this full resolution frame with denoise. But as I remember, my previous iteration for the same frame was something about 11 minutes. Maybe that's because of OBS running at the same time. Okay, let's have a look at statistics. Here we can see that maximum memory consumption was 94.6%. And let me remind you that I have 16 gigabytes GPU memory. And we can see that GPU runs at full power here. Okay, let's open result again and have a look at AOVs. Lighting contribution from environment, from lighting inside of hero building, and I can see that even with denoiser we still have details. Okay, some more light sources here. And actually I wanted to check utility AOVs too. World position, depths, albedo, yeah, and cryptomates. We have everything necessary for comp. And I think that's all I wanted to show you in Houdini, and we can go to Nuke. But before that, a couple more words. As you can see in this project, complex thing is to prepare and do shading for all the assets. As about lighting and rendering, nothing special here. And I would say that we don't have any artistic lighting here at all. As about render settings, we have only 1, 2, and maybe 3 and 4 settings that we need to tweak. And all other things can be default. But overall, I'm happy with this result and see you in comp. Let's do the final step in this project. Here you can see render and Nuke script. Script itself is really simple, it's just A over B with some lens effects. Let's start from the beginning and play back render. Yeah, you can see that everything works well. I like these ripples, these small water droplets on umbrella. Yep. Also we can mirror result and have a look at it again. Sometimes it may help. Okay, let's start with this shuffle node and extract environment lighting contribution. After that, we're doing the same with lanterns. Let me show you. These 4 lanterns and merging them. Also, I used cryptomate to have mask for these fabrics, and I want these parts to be a little bit brighter. Let me show you. You can see the difference. Okay, and the next part is lighting from hero building, this one. And I'm doing the same thing with Cryptomate, but for this bicycle. You can see that everything works well, I mean Cryptomates. Let me show you difference. Yep. After that, lighting from a background, I mean background building. 4 light sources here, and merging them. We can see this result. And finally, we merge all of these contributions. We can see it. Okay, now we don't have alpha channel, and we need to bring it back from, for example, from original EXR. And merging with sky. Also, we can use depth pass and add some air. Actually, it's subtle, but let's leave it. Sharpen. I want the render to be sharper because we have the denoiser here. Yep. After that, grading and some lens. We blur the whole picture and screen it. After that, adding some glow. And finally, optical flares. Let me show you this flare. Yep. In the end, we just adding grain, and that's it. Let me show you this grain. That's all we have in this comp script. Let's mirror this. Let's have a look at final sequence one more time. Here it is. And actually that's all I wanted to show and tell you in this project. I hope you found it interesting and learned something new. And for me it was a pleasure to tell you all these things. See you